In this module, you will learn about the slope-intercept form, and normal form of the equation of a line. You have already learnt about the equations for horizontal and vertical lines, and the point-slope form and the two-point form of the equation of a line. Suppose a line intersects the x-axis and the y-axis at two distinct points. Let us denote these points as P and Q respectively. Then length OP is called the x-intercept of the line, and length OQ is called the y-intercept of the line. Note that if OP is equal to A and OQ is equal to B, then the coordinates of point P are A, 0, and the coordinates of point Q are 0, B. The equation of a line having a given slope and either an x-intercept or a y-intercept can be represented using the slope-intercept form. Consider a line L with slope m that intersects the y-axis at a point A, which is at distance c from the origin. This means that the given line passes through the point 0, c. We already know the point-slope form of the equation of a line with slope m passing through a given point x1, y1. Substituting the values of the slope of the line and the coordinates of point A in the point-slope form and simplifying, we get the required equation as y is equal to mx plus c. This is the slope-intercept form of the equation of a line with slope m and y-intercept c. For example, let us find the equation of a line with the y-intercept 2 and slope -2/3. Using the slope-intercept form, the required equation of the line is 2x plus 3y minus 6 is equal to 0. Now, consider a line L with slope m whose x-intercept is given as d. This means that the given line passes through the point d, 0. Putting the values of the slope of the line and the coordinates of point B in the point-slope form and simplifying, we get the required equation as y is equal to m into x minus d. This is the slope-intercept form of the equation of a line with slope m and x-intercept d. For example, let us find the equation of a line with x-intercept 3 and slope -2/3. Using the slope-intercept form, the required equation of the line is 2x plus 3y minus 6 is equal to 0. The equation of a line having an x-intercept and a y-intercept can be represented using the intercept form. Consider a line L with x-intercept A and y-intercept B. Let's denote the points where the line intersects the x-axis and the y-axis as P and Q respectively. Therefore, the coordinates of point P are A, 0 and that of point Q are 0, B. We already know that the two-point form of the equation of a line passing through the given points x1, y1 and x2, y2. Substituting the coordinates of points P and Q in the two-point form and simplifying, we get the intercept form of the equation of a line as x upon A plus y upon b is equal to 1. For example, let us find the equation of a line L making intercepts 4 and 3 on the x and y axis respectively. Using the intercept form, the required equation of the line is x by 4 plus y by 3 is equal to 1. On simplifying, we get the equation of the line as 3x plus 4y minus 12 is equal to 0. The normal form is used to express the equation of a line when we know its perpendicular distance from the origin and the inclination of the perpendicular drawn to the line from the origin. Consider a non-vertical line L. Let OA be the normal or perpendicular drawn to line L from the origin. Let the perpendicular distance of line L from the origin or the length of perpendicular OA be P. Further, let angle AOX be omega. Thus, omega is the inclination of normal OA. Let us draw a perpendicular AM from point A to the x-axis. In the figure, note that distance OM represents the x-coordinate and distance AM represents the y-coordinate of point A. Let us find the values of OM and AM to get the coordinates of point A that lies on the given line. From right-angled triangle OMA, distance OM is equal to P into cos omega, and distance AM is equal to P into sin omega. Thus we get the coordinates of point A as P cos omega and P sin omega. Note that for the given values of P and omega, the coordinates of point A will remain the same no matter the quadrant in which line L lies. Now that we know the coordinates of a point on line L, we can find its equation if we know its slope using the point slope form. Let M be the slope of the given line L. Since OA is perpendicular to line L, the product of their slopes is equal to -1. Given that the inclination of normal OA is omega, its slope is equal to tan omega. Thus we can say that M into tan omega is equal to -1. This implies that the slope is equal to minus cos omega upon sin omega. We already know the point slope form of the equation of a line with slope M passing through a given point x1, y1. Substituting the values of slope M of the line and the coordinates of point A in the point slope form, we get this. On simplifying, we get the equation of the line as x cos omega plus y sin omega is equal to P. This is the normal form of the equation of a line, where P is the normal distance of the line from the origin and omega is the inclination of the normal drawn from the origin to the given line. For example, let us find the equation of the line whose normal distance from the origin is 6 units and the angle that the normal makes with the positive direction of the x-axis is 30 degrees. Using the normal form, the required equation of the line is under root 3x plus y minus 12 is equal to 0.